In this video, we will be teaching you how to take the normal Detour method using a declspec naked function, which is essentially just like shellcode, and we're going to show you how to convert it into a trampoline hook function in C++ that's going to take care of all of that stuff for you. What this allows you to do is redirect execution flow from one function to your own function and then back again without having hook recursion. That's the purpose of a trampoline, or using a gateway as it's called. If you love our videos, guidedhacking.com/donate or patreon.com/guidedhacking. The inspiration for this video was I just wrote a big guide on code detouring and hooking. It explains everything you need to know. So before this tutorial, you may just want to go over there and just brush up on some of the information there. This is the video that we're going to be building upon. This is just the regular detour using declspec naked. And then we have the how to hack any game internal tutorial. We're going to be using that video's code as a base because everything's already set up for us and we can just jump right into it. As always, make sure you've done the prerequisite videos, meaning this one and then this one. And then again, shout out to Jay Bremer. He wrote an excellent article years ago, API Hooking Demystified. Basically, almost everything you do in hooking is based on his tutorial. And from this little diagram, you can see exactly what we're going to be doing today. We have function A, which is the original function. We're going to make it jump to function B. Then it's going to call the gateway, which is going to return execution flow after our function executed, and then continue executing the original function. I've also made my own diagram here. This was the original detour from Solaire's video. This is the original assembly code, and we want to place our hook right here. And so we do a jump instruction, which jumps to our code. We execute the stolen bytes, and then it jumps back. What this function doesn't do is it doesn't automatically calculate the jump back address for you and some other things, and so it's more unwieldy to use. It requires more work. So what we're going to do is we're going to actually make a wrapper for the detour function, which is going to be our trampoline hook function, and that looks like this. So this represents the function that we want to hook, just regular ASM code. We're at the top of the function, and then we're going to create a jump that jumps to our hooked function. So this has our code in it, which can do whatever we want. In this case, we're just outputting the console the word hooked, and then we call the gateway. In the gateway, it executes the stolen bytes. The stolen bytes are the bytes that we overwrote with this jump here. And then we're going to jump back to the original function right after our jump. So if our jump instruction is 5 bytes, which it most likely is, that the gateway is going to jump back to 5 bytes after that. So the whole purpose of this gateway thing is to prevent hook recursion. Because if you took this out of the equation, we would execute the function, jump to our code, and then jump back to our function. And that would just call the same jump again. So the hook recursion, it would just jump back from here to here to here to here, and your game would crash. So in this case, we're going to jump to our function, do our code, call the gateway, execute the stolen bytes, and then jump back and continue execution right where we left off. So that's what we're going to show you and see now. If you download the attachment from the first internal hack video, you'll get the solution. So let's pop the sucker open. In most cases, upgrading a small solution like this represents no problem, so we're just going to go and do that. Little tip for you, now that we're here, this scroll bar is actually really awesome. I really enjoy this, but it's not default setting. So right click on your scroll bar and go to scroll bar options, and you can enable it by using map mode and setting source to wide. Then you can get a little preview of the code that you're going to be looking at. Now the goal here is, in this DLL, we have called create thread on hack thread, and it executes some code, and then it does this big while loop. The goal is we don't need a thread running with this while loop in it. We can have this code execute once per frame in the context of the game by hooking a function. In this case, we're going to be hooking the OpenGL function swap buffers. So if we look at the Assault Cube executable in IDA Pro and take a look at the import table, we can do Control F, swap buffers, and we can see that this is the function we want to call. Now what we're looking at here, the swap buffers function actually has several layers of abstraction here. So Assault Cube is written using SDL, and then swap buffers is a GL function, but it's actually it's exported by GDI. I'm actually a little bit confused about it myself, which is why we need to go and look at the OpenGL 32.dll file. And in this case, it's an exported function. We've already searched for swap buffers, and here it is. So everything is based, that SDL function is probably just a wrap around this function, which is WGL swap buffers. So this is the actual function we're going to hook, which is exported by OpenGL 32.dll. If we take a look at this function, we can get the function prototype. Everything's always easy with Hexarray's decompiler. If we click F5, it is a standard call, an integer return type, WGL swap buffers, and it takes one argument, which is a HDC, a handle to a device context. So the first step is we need to define that function in our local project. We need to define a function pointer to that function. We need to be able to get the address of that function, and then we need to make a copy of that function, which is going to be our hook function, where we're going to execute our code. So to do that, we can just do type def, and it is a bool is the return type. We know it's a standard call, so std call pointer TWGL swap buffers, and it takes the argument HDC. And what this is a function pointer type def, okay? So the T just denotes this as it being a template function. And so we're going to create a function pointer called OWGL swap buffers using that type. So we're going to use that type, and we're going to do OWGL swap buffers. And then we're going to define our hook function itself. So bool std call hkwgl swap buffers HDC. And so again, this O just originates. This is going to be a pointer to the original function. And then HK, this is our hook function. You can use whatever naming convention you want. That's just one that's been used for many years. So inside of our hook, all we're going to do is we're going to see out the word hooked to our console so that we know that it worked. Can't type today like usual. Now, at the end of this, we need to call the original function. And so we're going to do that by doing return OWGL swap buffers HDC. We're going to pass the argument, and that's it. In this case, this function has a return type, which is bool. So we have to do return and then the function call. So this function is going to get called, and then it's going to take the return value of that, and it's going to return this function using that return value. If your function does not have a return type, it's just a void function, you don't necessarily need this return. You would just call the function without it. So now we need to get the address of the original function. So let's just make some space here. We're just going to put a little area just for our code for this tutorial and keep it all separate for now. So the first thing we need to do is let's get this OWGL pointer, and let's get the address of it. Now this is exported. It's in the export table of this DLL, which is, so that's very easy to get. If this is just a random function in your game, you would have to calculate the address of it dynamically after you had reversed it and found it yourself. So in this case, what we're going to do is we're going to use the function get proc address. And what this function does is it gets you the address of an exported function. So we need a handle to the function, which is a handle to the module. So we're going to use get module handle. And OpenGL32.dll. We need to prefix this with prefix it with the L macro because this project was made with Unicode. And then the function name is WGL swap buffers. And we need to just end that. There we go. And now we need to cast this to the function pointer type that we're using. And so now that should compile. So on the next line, we're actually going to execute our trampoline hook. So let's define this in our little memory library we've been creating in mem.h. And we're going to have two functions. One is going to be bool Detour 32. Now this is going to be just like the one from Solair's tutorial. I think I've just changed a couple variable types, but not much else has changed. It is effectively the same. And then now we have our new function, which is going to be byte pointer TramPhook 32. It's going to take a byte pointer source, byte pointer destination, constant u in pointer underscore t length. Okay, and so basically this function is going to be a wrap around this function that performs the trampoline on top of the original Detour. So let's copy those two definitions, go over to the source file, scroll down, paste them in, and let's make some function bodies. And now we're just going to start defining them. So we'll just code these out and then I'll explain them to you. So first thing, if length is less than 5, we want to return false because it's not going to work for us because on 32-bit, the minimum jump size for a relative jump is 5 bytes. So that's just a little to protect you if you make a mistake of some sort. Then we're going to create a protection and virtual protect source, length, page, execute, read write, address of, cur protection, then uint pointer underscore t, relative address equals destination minus source minus 5. And after that, we're going to do the value pointed to by source equals 0, x, e9, and then we're going to do source plus 1 equals relative address. And we're going to have to wrap this with a typecast to a uint pointer underscore t pointer, and then we're going to dereference it. And then we have virtual protect source, length, cur protection, address of current protection. And then we're going to return true. So what this does, we have where we want to write our jump, and then what we want to jump to, and the length of this. Now, how is length defined? For that question, let's go to Cheat Engine, and let's go to Memory View, and we're going to do Control G to go to an address, and we can actually just type in the symbol name here. So WGL swap buffers. So here we are at the very top of the function. This is kind of weird. The first instruction is NOP. And then we have a push EBP, move ESP into EBP. And so the jump we're going to write is 5 bytes. The JMP plus the 4-byte address. So it's 5 bytes total. So when we write in that jump, we're going to overwrite 1, 2, 3, 4, 5 bytes. Now let's say we started writing our jump where this 83 is, okay? If we wrote 5 bytes, that would be 3 from the first instruction and 2 from the second. So our stolen bytes, if we put in 5, that would only execute half of the second instruction. So that's not going to work. So if we started writing the jump here, our length would be 6 bytes because 6 is the complete size of both of these things that we're overwriting. Up here, we only have 1, 2, 3, 4, 5. We're overwriting these instructions, so length 5 works. It has to be a minimum of 5, remember. So then what we need to do is we need to call virtual protect because the pages of memory that we're overwriting in, those do not have write permissions because they're an execution section. That's just how Windows security works. But it's easy to circumvent that. We just call virtual protect and we give it page execute read write permissions. We're making a copy of the old protection so that we can reset it later down here. Then we're going to calculate our relative address. So we have destination minus source minus 5. So that's the relative address from the source to the destination. Now the next line, we're taking source and we're changing that byte to E9, which is the jump instruction. It's the unconditional jump instruction. And after that, we're going to write our relative address. So we have the 0xE9 jump instruction, and then this is the address we're jumping to. Now, once that's all set, we've written our jump right here, and now we're just going to reset the protections to where they were. So down to the trampoline function. Same thing, we're going to do if length is less than 5, we're going to return 0. And then we're going to create the gateway. And we're going to do that by doing byte pointer gateway equals virtual allocate 0 length mem comment. We're going to OR it with mem reserve. And then we're going to do page execute read write. Remove this comma after mem commit, and then we need to cast this to be a byte pointer. So if that works correctly. Then we need to write the stolen bytes to the gateway. And we're going to do that by using memcopy _s, secure version, gateway, because we're so cool like that, length, source, and then length again. And then we need to get the gateway to destination address. This is basically the relative address we need to get from the gateway back to the original function. So similarly to the regular detour we had, uint pointer _t gateway relative address equals source minus gateway minus 5. Then we're going to add the jump opcode to the end of the gateway. And we're going to do this by doing gateway plus length equals 0xe9, just like we did before. And we just need to cast these and then dereference. Then next thing, write the address of the gateway to the jump. And to do that, we do gateway plus length plus 1 equals gateway relative address. But that does not compile. We need to wrap these and cast them and dereference, just like we did before. We need to add 2 more of these here. And that's a 1. There we go. And then we need to perform the detour. You can probably, so this is basically a wrapper around this Detour 32, right? We're making the gateway and then we're just calling Detour 32. You could probably do this with less code, but when I was working on this, it's just easier just to call it and be done with it. Why should we have to write all this code again, you know, for a second part? So then we return the gateway. Now this is kind of an interesting part, this return. I'm going to explain that to you later, but you need to get that gateway out of here because you need that later. So we call virtual allocate. We're looking for, if you're wondering why we use mem comment, mem reserve, just go look at msdan virtual allocate. It'll explain everything to you. This is just a pretty standard way of creating any code pages where you're going to be executing, okay? And of course we need execute permissions to do so. So that will return us the new address of memory, which we've allocated for ourselves. That's going to be our gateway. We then are going to copy the stolen bytes into the gateway. Those are the bytes that we overwrote with our jump, because we still need to execute those, or else the stack will get corrupted, right? So destination is gateway, the size of the destination is length, source buffer, and then the size of the source buffer. So then we get the address, same thing we did before, source minus gateway minus 5. That will get us, that's like our jump back address, okay? So that resolves that distance for us. We write the E9 unconditional jump, and then we write the address right after that jump, which is just our gateway relative address. And then we call detour, and that basically writes the jump from the gateway back to the original function. Sorry, that's what writes the jump from the source address to our function, and then our function calls the gateway later, and then the gateway does the jump back. So key part here, trampoline hook returns the gateway. There's probably other ways to do this, but this is the way I see a lot of people do it. So let's see if this compiles. It does. Wow, we got it perfect first time. Yay. Okay, so now we need to do the trampoline hook itself. So we're going to call mem tramp hook 32. We are going to do OWGL swap buffers and HK WGL swap buffers as our source and destination arguments. The length of that jump we know is going to be 5, and then we just need to cast these to this type. We're actually going to do byte pointer actually. And then remember is we need to set this variable. So we're going to do OWGL swap buffers equals the address returned by this, which is the gateway, and we're going to cast it to the correct type. Let's see if that compiles. And it does not. Why? We need our scope resolution operator, of course. Now we should be good to go. Oh my. All right, now we compile. Let's take a look. Now, before I said the return value of the TrampolineHook function is the gateway, and why we need to set that is because this is our function pointer up here to the original function. So if this is not set to the gateway, then that's what's going. It's just going to call the original function, which is going to call our detour, which is going to call the original function, which is going to call a detour. So the whole point of this whole trampoline hook is to take care of all that for you by utilizing the gateway and preventing hook recursion. So now let's see if this works. Let's grab our assault cube. Let's attach our local debugger. Attach the debugger again. Once we're here, let's set a breakpoint right here. And assault cube is running. We have our injector here, so let's inject. So if we step over this, we can see, we go over to autos here. Where is it? Locals. Yeah, so swap buffers now has the correct address. It got it via get proc address. Let's step into the trampoline hook. We're going to get our gateway address, which is important. Let's go to cheat engine and let's take a look at that. So let's do go to address, and we're going to go to 040F0000. So this is going to be our gateway. All right, once we step over this mem copy, we will see that our gateway now has those stolen bytes, the NOP, the push, and the move EVP ESP. So this is our, we're going to add a comment here, and we're just going to call this gateway. And let's keep stepping. Once we've done that, we're going to add in the jump and then the relative address. So now you can see we have stolen bytes and then jump. Now we're going to step into the original detour function. And this is what's going to be jumping from the source function to our function. So in order to see that, we need to do go to address, and we need to do WGL swap buffers. So we see our stolen bytes here. We haven't overwritten them yet. And if we step over this, we're going to see the jump placed in there, and then the relative address. And then virtual protect is going to put the original protections back, and then we're going to return true. So that's done, and now we're going to return the gateway. So once that's finished, we have a fully functioning trampoline hook. And so let's view that by going into, what we need to do is, we need to detach the debugger. That's the first thing we need to do. And we will detach all. Game is still running. We can see that function. This is calling hooked here, so that is working correctly. Now let's go to our swap buffers and let's add a breakpoint. So we've got our breakpoint has just been hit. It's going to jump to our destination function. So we're going to step into that. This is just a little jump table, and now it's going to jump into our function, okay? So you can see that this function is this function right here, okay? And we're going to see it. It's going to be calling C out using the word hooked. And then if we scroll down a bit, we will see that after it does that, it's now going to call this function. And if you remember this address, that's 40F00, that is our gateway. So let's put a breakpoint there and let's run it. So now we're hit on our calling to the gateway. And that's where this is. So right now we're at return OWGL swap buffers, which is our gateway. So let's step into that. Now in the gateway, we see the NOP, the push, and the move. Those are the stolen bytes. And then we have our jump. And if we click that, we are now back in WGL swap buffers, and we're directly below the jump. So this is exactly what we were trying to do. Yeah, so that worked beautifully. So now what we want to do is we just want to modify the code a little bit just to be a little different. So we want to put our code in our hook, so we don't need that while loop. So now to do that, we can't have, some of these things need to be in the global namespace. So we're just going to copy these. We actually don't need this line. This is from the old tutorial. And what else do we need? We have that. Our while loop we no longer need. So we're going to get rid of that. We don't need a sleep. And we're just going to grab these functions, cut them, and paste them right in here. And now that should compile, I believe. And it fails because of an illegal line break. Oh, we don't need the break anymore. Okay, so this is leftover from, this is what was our way of ejecting our DLL. We actually can't eject the DLL yet because we don't have an unhook function. I'm not going to cover that in this video, but it's pretty easy. So let's remove that break. When we deleted that break earlier, and that was the ejection method, we need to comment out that line, and I believe that will fix it. So let's inject again. Now we should be good. So now our hotkeys for our hack should work. So numpad 1, 2, 3, and 4. So now we have unlimited ammo, unlimited health, and whatever other hacks we had put in here. What else do we have? Yeah, unlimited health, unlimited ammo, and then no recoil. No recoil works. Yep. So that's beautiful. So all this is getting executed inside of our hook, and we don't need a while loop or any sleeps or anything like that. Now, the benefit of putting it in a function like swap buffers or the Direct3D equivalent is it executes once per frame. So if your hack is executing 60 times per second, that's pretty damn good. So yeah, this video came out pretty good. I got to show you something a little more advanced, and I hope everyone's enjoying the fact that we're pushing out 1 or 2 videos per week. Again, if you like our videos, guidedhacking.com/donate, patreon.com/guidedhacking, and we'll see you next time.